Hello everyone, this is the video lecture for Algebra 1314. We're on the very last video. Woo! 11.7. So this is not a hard section, but we do want to talk about it, of course. Probability, there's a formula for it. It is selected over total. We'll use that exact same formula every single time. And we've already been seeing selected and total back from the previous section with the NPR and CR stuff, okay? And we'll see that again here a little bit too. So selected over total as we go. They're trying to say here that it's from 0% all the way to 100% probability of things happening. You can't have 200% probability of something, so there it is. Classic probability. I call them dice, cards, coins. It's things that are fixed that won't change over time. Okay, you'll always have the same amount of dice, cards, and coins, that kind of thing. So this right here is so important. I would say you're going to use it like 8 times here in just a few seconds. So come back, reference this, use different colors, erase and draw again. I don't know. We'll figure it out. But I'm going to come back to this. I'm going to scroll back up to this a lot. So it says 52 card deck, and you're dealt Queen of Diamonds. Queen of Diamonds. How many did I select? 1 selected. How many total? 52 total. And that's your answer, 1 out of 52. They want fractions, if at all possible. If they give you decimals, then you can use decimals. So then it says delta 2. So then 2s. Their 2s are right here. So how many 2s? I got 4 selected. How many total? 52. Total. Don't know why I was saying that again. You can reduce that down. I think it's just like 1 out of 13 or something, but we can always use Desmos to make sure. There you go. Cool. We'll come back to this. I will scroll back up and use this again here in a little bit, okay? So we have a 12-sided dice, basically 1 through 12, and it says what's the probability of greater than 2? So that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many do I have selected is 10. How many total is 12. You reduce that down, I think it's 5 out of 6. And there it is. You toss a coin 2 times. What's the probability of exactly 1 head? So 1 head, 1 head. So that's 2 selected out of 4 total. And that would be 1/2. Notice that I'm physically selecting them. Even right here, I'm going to physically select them. It says at least 2 tails. At least 2 tails. So that's going to be this guy, this guy, this guy, this guy, this guy, this guy, here, 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 here. I'm drawing on top of them. You should be doing this too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 selected, 16 total. That does not reduce, and there you go. That's all we're doing. It's not hard here, not hard. This one's hard, but that's okay. We can do this. So we have a lottery, which we saw last time is the NCR stuff, and we're doing 47, and you're selecting 8 of them. So that's kind of like what we're going to be using. Notice, though, it says 1 ticket, so you got 1 ticket selected, but then this NCR thing is going to tell us the total. Oh my. Let me just write that one down. So this is my, let me just do that right there. Okay. So 1 selected, and then I got 314, 457, 495 total. There's no way to reduce that down, so like that's your answer. Yay. Then it says you got 200 that you're now selecting. So 200 selected divided by the exact same total. Now, Desmos might not do this for you, like on your homework, depending on what's going on. I would just be a little careful. Try it out. If Desmos doesn't work, maybe just try a different website for like this one problem. Like GeoGebra might do a little bit better. I'm not really sure. Desmos has been really awesome, okay? And they're the sponsor of this video, of course. I'm just playing. I don't know if I'm going to get in trouble for saying that kind of thing. Anyways, this is just a weird one, and sometimes it doesn't come out pretty. Just be careful, watch it, try. I don't know. We'll figure it out together. Send me complaints if it doesn't work out on the homework. Okay. Maybe they'll change it or something. Good though? Good. Okay. So empirical probability. So opposite, I guess, or different than the classical. This is like with charts and frequencies and stats and stuff like that, like baseball stats and other little things like that. Things that will change over time. That's supposed to be a frequency. Anyways, still selected over total. So we're going to do the same thing as all the other times. Now this one is like way... No. Yeah. This is fine. This one's fine. It's this one, I think. Yeah, this one's just way out of it for some reason. I'll show you how to work it, but it's jumping ahead. This one's fine. The other one's going to be a little weird. So it says, what's the probability of someone in the Army? Okay, so Army, we got these folks right there, yeah? So just to make it easy as possible, I mean, we got 39 in the Army, so 39 selected. And then what's your grand total is the 96. Grand total. Now, this is decimals allowed. You can even see it says decimals, so that's a good thing. We like decimals because then we like Desmos. Yeesh. Okay, there we go. Cool. So like 40-something%. This one is definitely an oddball early, so we have to watch out for it. But see this like from among, okay? Now, I'm going to show you how to do it. It's very simple, but we'll be seeing the actual formula concept for it later. Whatever. So from among males, as in like I only want to look at males, so the females are no longer here, and that total no longer makes sense. I am literally getting rid of it on top of my paper. This is what I do. Okay? On your exam, you draw on your monitor. No. Okay. So, says, okay, what's the probability of 50 or more? Oh, well, that's these guys, and there's my total. So I got 29.4 selected out of 78.2 total. Put it together. And I get my answer, 37,595. Sweet. Okay. Complement means opposite. And so what they're saying is like whatever your probability is, it's 1 minus your probability. Again, 1 means 100%. So just opposite. So 50-50, 30-70, 20-80. You get the idea. Okay, so you're dealt one card. What's the probability of not a club? Not a club. Okay, so whoop, 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 right back here. So clubs are these guys right here. There's 13 of them. So they're saying not a club. So everybody else essentially. So there's a few ways we could do this, obviously. But I'm going to say for the club, it would be 13 clubs out of the 52 total, right? So that's awesome. But I'm saying opposite. So the formula is 1 minus that amount. Like I'm literally doing 1 minus 13 over 52 to get the answer. Of course, you can count the other set of cards, okay? It would be, 39 of the other cards. If you want to do that, that is totally fine. I'm just trying to show you another way. So 3/4 is my final answer, 75% essentially. Boom. Okay, and moving on to the next topic. So mutually exclusive means that there's two events that cannot occur at the same time. Two events that cannot occur at the same times. So I try to make a lot of silly examples in class, and I'll try here again. So can you fly in a plane and drive at a car at the same time? And you're like, dude, there's flying cars, man. Okay. Or you like park your car on a plane and then you drive off, or you fly off, I guess. I don't know. There's all kind of weird things. Can you chew bubble gum and eat a hamburger at the same time? And you're like, yeah, Chad, I got 2 cheeks. Just like, okay, gosh. Challenge accepted. I get it. But the point is, there's two events that don't occur at the same time. There's no intersection between them. That's what mutually exclusive is. So there might have some questions about it. You just have to be a human. You have to be a human to be able to answer them. Okay, got to be a human. Okay, cool. So, but this is a pretty cool little formula. They are going to use it once in a while. I used it on the workbook when I did it. I don't like doing it though, honestly. So we'll see about that. The big takeaway is right here, and I'm gonna prelude, I think, to another one. If I'm gonna just scroll right quick down to right here, this guy. Oh, let me back my little drawing thing. There we go. This one and this one put together, I'm gonna show you something like right here. I'm gonna write it down. When you see the word or, it typically means to add. When you see the word and, it typically means to multiply. Okay? That's just a general understanding of how this kind of thing works. So or means add, and means multiply. That's kind of what's going on, okay? So that's the takeaway from this. Okay? There's a formula. I might reference it maybe if I care enough. But let's keep going. Oh, back to the cards. So it says, what's the probability of a queen or a 2? See, I'm going to add them up, basically, right? So I've got 4 queens, and I've got add 4 2s, right, selected. Again, my total is 52. So what's actually in my numerator is 8, right? Oops. Okay. Same thing. So 8 over 52, 2 out of 13. There you go. That was part A, by the way. I kind of wrote pretty big. Part B, it says a queen or a 2 or a 3. So you're adding them all up. That's 4 plus another 4, all over 52. There we go. So 12 out of 52. They want a fraction if at all possible. Sweet. The last one's different. It says ace or club. I am still adding, but I want to go and show you how this works. So ace or club, right up here. Do you think I can erase that stuff? Oh, nice. Okay, ace or club. Ace or club. Okay. Cool. So those are my selected. Here I had 13, and then I had 3 more. Notice that I don't want to select him twice. You don't want to select him twice. You don't want to select him twice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so again, 13 plus 3 more is 16. 16 selected, okay? And so then we got 16 selected over 52 total, math, and you're done. Okay, 4 out of 13. Cool, there's your answers. That's how you do it. And notice I keep on going back to that same picture. Unless you know cards very well, I would say go back to that picture every time and just draw on top of it. Erase, draw on top. Okay, we got Twister. I don't know if y'all even know what that is, that kind of old game or whatever. Anyway, so we got a spinner, and they're saying greater than 3. So that would be a 4, a 5, a 6, a 7, or an 8. How many selected? 5 selected. How many total? 8 total. And that's it. It's 5 out of 8. So you're done. Conditional probability is that given of from, among, is another way to say it. So given or from among. And that is what we were talking about way earlier right here, okay? So that's why that problem was a little weird. But essentially what you're doing is you're scratching through things that you don't need, and then you relook at the problem. That's all it's really getting at. Didn't you read that from this? Come on, I'll let you read it. All right, that's what you got, right? Okay, exactly. All right. And then they don't have a question about it. We'll get to it next time. Independent. So independent is when 2 events don't affect one another. Okay, so they don't affect one another. Okay, so a butterfly flaps its wings on the coast of Africa, and there's a hurricane in the Gulf. That's not really a thing, I know, but some people say so. Some other things that don't affect one another. Today for lunch, I'm going to eat a sandwich. Did you know that? Well, and again, this is being recorded, so it'll probably be a whole different day. But then, does that affect what you're going to eat for lunch? You might be thinking, though, oh, yeah, it does, because now I'm thinking, oh, that sandwich sounds really good, Chad. I mean, I'm trying hard here, okay? I'm trying hard. So two effects that don't affect one another. Dependent is the opposite, is not independent. There you go. Independent. I don't know. Good enough. They might ask a question or two about it, but it's not too big of a deal. There's my and means multiply. And means multiply. And let's do this thing. So, a single dice is rolled twice. So there's two of them. We need an odd number and then something greater than 2. So 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. And I'm selecting an odd number. And then over here, it's got to be greater than 2. Okay, so here I got 3 out of 6. Here I got 4 out of 6. And then and. Notice that keyword right here, and. Okay, so I did the first one and, then I did the second one. And means multiply. Multiply them together. Desmos for sure. And we got 1/3. Sweet. So there's your answer. Okay, I really like that problem, and I want to do this one, and then I'll do that one because this one's just meh. So okay, toss a coin 3 times. What's the probability? All tails. So I toss a coin, I toss a coin, I toss a coin, I get tails, I get tails, I get tails. Well, each one of these is a 1/2 situation. So I toss a coin, and I toss a coin, and I toss a coin. Half times half times half. You should already know this one is 1/8, but let's just do it so that you can see. Bottom, bump, 1/8. Awesome. So this one's a cool one. It's a little different than the others. So Elizabeth bought a box of donuts. We got 24 donuts total. 2 are jelly, 5 are lemon, 17 custard, and you can't tell which one's which. So you just grab one and eat it. Grab one donut, eat it, and then you grab another donut and you eat it. So what's the probability of custard and then a lemon? Okay. So first off, I need to say custard and then a lemon, right? And means multiply. So custard. How many custards we got? We got 17 custards that we can select from, and then I still have a total of 24 donuts in total in the box. But then when I go for my lemon, how many lemons do I have left? No, I got 5 lemons, right? Selected. But how many total now? Because I already ate one. It's 23. 23 total. Okay, so I had to change that a little bit there. And if they had said something else like custard and custard, it would have gone from 17 down to 16. So it just kind of depends on what they're asking for. Just watch out for that 23. You got to have that 23 there. Yeah, I'd rather take a decimal. 1, 2, 3, no. There you go. 15% probability. Cool. So that's pretty cool. Just watch out for those little tiny things like that. Wait, that's it? That's literally it? That's the end. Oh my gosh. Okay, cool. So we're almost done. From among. See it right there? From men. So again, same thing. I'm going to get rid of the females and the total. Okay? I'm getting rid of it. Totally gone. Go away. No. All right, that's better now. Okay, so it says find probability of married. So married, total. There it is. So 69 selected. I got 129 total. You don't have to write selected and total every time. I'm picky like that because I'm a teacher. 5, 3, 4, 8. There it is. All right. This says, what's the probability of the sum of these numbers being 11, right? So that would be 6 and 5 and 5 and 6. There's really nothing else that'll do that. So there's 2 that are selected, and out of all these, this is 6 times 6 is 36 total. So that's 1 out of 18, by the way. I can do math without Desmos. Yeah. Last one's a card question, so we'll scroll back up here in a second. This is probability of an 8 or a black card. So here we go. 8s or blacks. 8s or blacks. Let's finish this problem up. Here we go. Get rid of this, get rid of this. Okay, there we go. Okay, so 8s or blacks. You're not counting the cards twice. No. You count them one time. That's it. Let's count them all. Get rid of this. I don't really care anymore. There we go. Okay. So out of this, I got 26 cards, by the way. So 26 out of this big old block here. And then 27, 28. 28 selected. Okay, 28 selected. Out of the 52, of course. So here we go. Last one. So 28 selected out of the 52 total. Calculator. Let's get something cool. And, oh, there we go. Done. We're done. We're done. We're done with this entire course. So that's awesome, right? The takeaway from this section, I really hope that you're seeing that I'm literally physically selecting them. And when it says from among, I'm like getting rid of everything else. That's the important part that you need to learn from this section. Just go ahead and draw all over this thing, okay? Because that's how you're going to get it right. Okay. This has been a fun ride, guys. And it's been so fast. So, anyways, cool. Look at my other videos, too. Thank you very much. And have a great day.